Lesson 2-2 is on adding rational numbers. All right, now we're not going to actually be adding the two decimals or the two fractions every single time today, because we know if we have a negative decimal or a negative fraction, we have to kind of pay attention to our signs, and we're still following our same sign sum different sign difference rule. All right, first examples, I have decimals, okay? Make sure when you are adding or subtracting decimals that you line up the decimal place values. We also will always need to put the decimal that has the greater absolute value on top when we are setting this up. So here I have 2 7/10 plus a negative 3 4/10, or 2.7 plus 3.4. All right, the larger absolute value is 3.4. So I'm going to put that number on top and 2.7 beneath. Now, based on our signs, we have to figure out if we're going to add or subtract. Well, 2.7, positive. What sign is in front of 3.4? Directly in front of 3.4 is this minus or negative sign. So I'm putting a minus or negative above the 3.4. So going back to last chapter, we have different signs that tells us to subtract. So I need to subtract those two numbers. All right. When it's set up like this, we cannot take 4 minus 7, so we need to borrow from the 3, make it a 2, and now make that 4 a 14. Now 14 minus 7 is 7. Bring our decimal straight down. 2 minus 2 is 0. 0 7/10, or 0.7. Now, once again, with adding and subtracting, we always have to ask ourselves what number is farther from 0. 3.4 is farther from 0. 3.4 has a minus or a negative sign, so our answer has to be negative. So we are combining what we learned last chapter and just adding on to it this chapter. Next example, negative 3 7/10 plus negative 7 5/10. All right, this has a greater absolute value, so this needs to go on top. All right, now we need to find out what I need to do to those two decimals. Well, this 3.7 has a minus in front of it, and so does the 7.5. Our signs are the same, so we add. So now I know I need to add those two numbers, or those two decimals. 5 plus 7 is 12. Carry my 1. 7 and 1 is 8. 9, 10, 11. And we bring our decimal straight down. 11 and 2/10. What number was farther from 0? We have to remember to ask ourselves that when I add or subtract, right? 7.5 was farther from 0. It has a minus or a negative, so our answer is negative 11.2. Moving on. When I add or subtract fractions, we have to have a common denominator. Our two bottom numbers have to be the same in order to add or subtract. If they're not the same, we need to make these fractions, sorry, I'll recorrect that. And we need to convert these fractions, make them look a little different, but still mean 4/5 and still mean 6/7 with denominators that are the same. So we need to find the first set of multiples that 5 and 7 have in common, okay? So if I were to take 5 and just start naming off my multiples, 5, 10, 15, 20, 25, 30, 35, and then start naming 7, 7, 14, 21, 28, 35. The first number that they're going to have in common is 35. So that has to be our common denominator. All right, in this case, yes, we are just multiplying 7 times 5 to get 35. You can do that each time, but that's not the best strategy each time. You want to find the smallest denominator that they both have in common, or the smallest factor, smallest multiple that they have in common. In this case, it was 35. So now we need to figure out, we're just focused on, this side. How did I get from 5 to 35? What did I multiply 5 by to get to 35? I took 5 times 7 to get 35. So to keep this fraction equivalent, we have to do the same thing to the numerator. If I took 7 times 5 to get 35, now we have to take 7 times 4 to get our new numerator. 7 times 4 is 28. So 28 over 35 is the same thing as 4 over 5. This is just reduced. But remember, we had to change it to that so we could get a common denominator. What did I multiply 7 by to get 35? 7 times 5 is 35. So to keep this fraction equivalent, I need to take 5 times 6 to get 30. Once again, these two fractions mean the same thing, one's just simplified. Now, my denominators are the same, so I can add. 35 goes in your answer. Once you have a common denominator, that stays in your answer. Now I just need to add our two top numbers. 28 plus 30 is 58. Okay? Now we need to convert this. This is a improper fraction. We need to convert this to a mixed number. So 35 goes into 58. Remember, top number goes on the inside, bottom number goes on the outside. 35 goes into 58 one time. Now we're going to make a mixed number out of this. Whatever I get after I subtract goes in my numerator, and whatever I divided by goes in my denominator. So 1 and 23/35. All right. The reason I added those were because my signs were the same, right? So same sign sum, we add. And our answer is positive because this 30 was farther from 0 compared to the 28, right? Here, -3/10 plus 1/5. I do not have the same denominator, so we need to get the same denominator. Okay, what's the first multiple they have in common? Well, if I were to take 5 and start naming the multiples of 5, 5, 10, 15, 20, and 10, 10, 20, right? We already have a common multiple in 10. Okay, what did I multiply 10 by to get 10? Well, I multiplied 10 times 1. Our fraction needs to stay negative. So in order to keep these fractions equivalent, I take 1 times 3 and get 3. What did I take 5 times to get 10? 5 times 2 is 10. So I take 1 times 2 to get my new top number. Now, we have to look at our signs on these fractions. This 3/10 is a negative 3/10, and I have a positive 2/10. So my signs are different. So we know when I have different signs, we need to subtract. So I need to take 3 minus 2 to get 1. Is 3 or 2 farther from 0? 3 is farther from 0, so 3 has a negative above it, so this 1 has to be a negative. And then we know our denominators just stay the same. All right. If I have a mixed number, I want you to convert them to improper fractions first. Okay, so we know we need to multiply your denominator times your whole number. 3 times 1 is 3. And then we add the numerator. So 3 times 1 is 3 plus 2 is 5 over 3, and it is a negative fraction. Bring down this. 3 times 1 is 3 plus 1 is 4. Now our denominators are already the same, so I don't need to do any more there. I don't need to multiply and convert to different fractions. Pay attention to our signs. They are both negative, same sign sum, so we add 5 and 4. 5 plus 4 is 9. 5 is farther from 0, 5 is negative, so 9 is negative, and the denominator stays the same. Now, if I reduce that, this should say -9 divided by 3. Well, 3 goes into 9 3 times perfectly in different signs. -3. Last example, 2 plus -7/2, or -7 over 2. If you have a whole number, all right, it can be written as a fraction. Remember, we can put any whole number and divide it by 1, and it means the same thing. So 2 over 1 is the same thing as 2. So let's make this look like a fraction, since I'm dealing with adding fractions right here, right? So now my denominators are 1 and 2. The first multiple that these have that are in common is 2. So my common denominator is 2. What did I take 1 times to get 2? 1 times 2 is 2, so 2 times 2 is 4. 2 times 1 is 2, so -7 times 1 is -7. Now I have the same denominators. Pay attention to our signs. Different signs tell us to subtract. 7 minus 4 is 3. 7 is farther from 0. 7 is negative, so our answer is going to be negative over 2, which converts to -1 and a half. All right, homework, page 54 and 55, 1 through 9, 10 through 24 even, and 33.